Today we're going to talk about inverses of relations and functions, section 7.2. We have talked about this a little bit. We found some inverses. What was that, back in chapter 9? I think we did some inverses of graphs and equations. Very similar, okay? But inverses of relations and functions, section 7.2 today. First thing we're going to talk about, to graph an inverse relation, reflect each point across the line y equals x. Okay, well, that's good, but here's what you really need to know. Or you can switch the x and y values. Okay, and that's the one that we've done before. So you can switch the x and y values in each ordered pair of the relation to find the ordered pairs of the inverse. Okay, so to find the inverse, really what we're going to do is we're just going to flip the x and the y, and that is then the inverse. So for instance here, remember relations instead of ordered pairs. So xy, I have 0, 3, 1, 6, 4, 9, 6, 10, and 10, 11. To find the inverse, what do? I just flip them all. So I get 3, 0, 6, 1, 9, 4, 10, 6, and 11, 10. Notice my inverses. They are like flipped across that line. They're kind of mirrored images of each other. They're inverses. Okay, domain and range here. Domain, recognize. They have, domain is the x values. So it's all the x values from 0 to 10. So it says 0 is less than or equal to x, which is less than or equal to 10. Range is my y values. So range y values here was 3 is less than or equal to y, which is less than or equal to 11. Now, what did we do to find the inverse? We flipped the x and the y, right? So what happens to my domain and range? They just get flipped. So my domain now becomes my range. Notice it's a y here. And my range then becomes my domain. And notice it is an x. So really, when you're talking about domain and range, you just got to find it once because the inverse is going to be flipped. Same thing. So let's look at number 1 here. Complete the table to find the ordered pairs of the inverse. Graph the relation and its inverse. Identify the domain and range of each relation. I have a relation here. I have the ordered pairs. 0, 6, 2, 10, 5, 12, 8, 13, and 10, 13. I want to find the inverse here. So to find the inverse, I'm going to do what with the x and y? I'm going to flip them. So I get the ordered pair 6, 0. Then I get the ordered pair 10, 2, 12, 5, 13, 8, and 13, 10. And if I wanted to, I could graph those. I had 0, 6, 2, 10, 5, 12, 8, 13, and 10, 13. So there was the top one. And then the bottom one would be 6, 0, 10, 2, 12, 5, 13, 8, and 13, 10. Notice how those are just flipped across that line. Okay, domain. I want to find the domain here. Domain is my what values again? Domain is my x values. So domain is my x values. Well, what does my domain go between? From what values to what values? Goes from where? Of the relation. First, of the original. So x goes from 0 is less than or equal to x, which is less than or equal to 10. And what about my range? My range goes from what values? 6 is less than or equal to y, which is less than or equal to 13. Again, I got that from looking at my y values right here. Now I want to find the inverse. So what happens to my inverse? My x and y's just get. So let's do the domain here first. So I take my range up to my domain. My domain is going to be x is between what values? Nope. 6 and 13. And what about my range then? 0 and 10 right there. Because that's domain and range. Feel pretty good? Good. Take a couple seconds to try number 2. Graph the relation and connect the points, then graph the inverse. Identify the domain and range of each relation. Take a couple seconds, try this one on your own. Alright, so let's look at this here. First thing we're going to do is we're going to plot the ordered pairs and draw a curve. So I have the coordinates 0, 3, 1, 4, 2, 5, 4, 6, and 6, 7. So I have that right there. Okay. Identify the domain range. What's the domain of the original relation here? What's the domain of the original relation, Andy?
X is less than 0 is less than or equal to x, which is less than or equal to 6.
And what about my range then?
3 is less than or equal to y, and 7.
There you go. So 3 is less than or equal to y, which is less than or equal to 7. Now I'm going to switch my x and y values. So I'm going to switch the x and y values. So if I were to make my little chart here, I would have values of 3, 0, 4, 1, 5, 2, 6, 4, and 7, 6. So I plot those coordinates. 3, 0, 4, 1, 5, 2, 6, 4, and 7, 6. So there's those coordinates. Now it says identify the domain and range of the inverse. What's the domain of the inverse going to be, Jack?
Is less than
3 is less than or equal to?
less than or equal to x, which is less than or equal to 7.
Nice job. And what's my range going to be then, Jack?
0 is less than or equal to x, which is less than or equal to 6.
Less than or equal to y,
Y.
which is less than or equal to 6. Nice job. Because again, domain and range are just flipped. Good work. So that's inverses. Okay, again, main thing about inverses is you're going to switch what two letters? X and Y. Next thing we're going to talk about is inverse operations. Inverse operations undo each other, like addition and subtraction, or multiplication and division. Those are inverse operations. In a similar way, inverse functions undo each other. All right? So use inverse operations to write inverse functions. The inverse function f of x is denoted by f inverse x. So it's f to the negative 1 power x. If I give you the function f of x equals x plus 8, what's the inverse of addition? It would be, so the inverse of that is f inverse of x equals x minus 8. Okay, so we're just doing opposite signs here. And then again, what can I do to check this? Well, I can pick a value of x. Let's say I try x equals 1. Okay, if I plug x equals 1 in here, I get 1 plus 8 is 9. Now again, inverse, remember x and y are switched. So let's take 9 and plug it into the inverse. 9 minus 8 is 1. It checks out to be the same number I started with. So if you plug it in back to the inverse, then you get the number you started with. All right? Same thing on the next one here. Function, f of x equals 5x. What's the inverse or opposite of multiplication? Division. So inverse, f inverse of x is x divided by 5. They said, well, let's try x equals 2. Okay. Well, what's 5 times 2? 10. I take 10, I plug it into the inverse function now. 10 divided by 5 is 2. That's what I started with. It comes right back out. And that's how you check to make sure they're the same. So let's try number 3 here. Use inverse operations to write the inverse of each function. Number 3, f of x equals x minus 4. All right, so I want to write the inverse of that. How do you suppose I would write the inverse? What did you say? X plus 4. Now it said, well, let's check it with x equals 5. Okay, so f of x equals 5 minus 4, and I get 1. Does everybody agree? So I'm going to take that and I'm going to plug it into my inverse function now, which is 1 plus 4. What's 1 plus 4 give me? 5. And look like that, we get right back to the original. Okay, so that's how I check to make sure that it's the true, correct inverse function. Number 4, f of x equals x divided by 6. What's the inverse of division? So I have f inverse of x. Ooh, that's a bad x. Equals 6x. Well, it says use x equals 12 to check. So I have f of x equals 12 over 6. What's 12 divided by 6 give me? 2. I'm going to plug that into my next function. So f of x equals 6 times 2. What's 6 times 2 get me? Hey. Just like that, we are back to the original function there. Alright? Inverse operations, pretty straightforward. Again, just thinking opposite signs. Or opposite operations. Take a couple seconds to try these four on your own. Alright, so let's look at these here. And again, if you wanted to check, you could check with x equals 1. It doesn't give you any value to check, but x equals 1 is always a pretty good number to use. Okay, or 0. 0 works sometimes too. So number 5 here. f of x equals x plus 3. What would the inverse of that one be? What do you say, Phil? Yep, that's just x minus 3. And if I plugged in 1, that would give me 4. Then if I took 4 and plugged that back in, I would get back to 1. Okay, nice job. 6, f of x equals 14x. What would the inverse of that one be, Mono? Very good. X divided by 14. And again, if I plugged in 1, well, that'd give me 14. Take 14 down here. 14 divided by 14 is 1. And we're right back to the top. What about number 7? Mr. Melidi, what are you thinking there?
I had negative x over 4.
Hey, had what?
Negative x over 4.
Negative x over 4. Nice job. Why'd you put that negative up top? Yeah, because you don't usually associate negative in the denominator. Nice job. Good work. He's like, I don't know. I just did because I thought I had. Yeah, that's right.
That's what you had to do. I just confused.
Okay. Yeah. And then if you plug it in there, you get what? Negative 1/4. And let's say you take, or wait, wrong one. Whoops. There we go. If I plug it into here, I get negative 4. Then if I plug it into my inverse function, I end up getting 1, which goes right back to the top. So that's good. Number 8's the tricky one. Who thinks they got number 8? Anybody want to take a guess? What do you got?
X over 3 plus 12.
So close. Popular answer, not it though. It is actually x plus 12 all divided by 3. It is x plus 12, all of it divided by 3. Okay? Because here's what happens here. Let's say the popular answer here, as what Mark said, was the popular answer is x over 3 minus 12, right? Or plus 12. Does everybody agree that's probably the popular answer here? But what happens here when we check that? When I plug 1 in here, I end up getting negative 9. Does everybody agree with that? 3 times 1 is 3, minus 12 is negative 9. If I plug negative 9 in here, negative 9 divided by 3 is negative 3. Negative 3 plus 12 is 9. Does that get me back to the original? No. Okay. What happens here is this one's a little bit more difficult here. This was what? X plus 12, all of it divided by 3. Remember, what is f of x fancy for? F of x is fancy for y, isn't it? So really this is y equals 3x minus 12. Now, to find the inverse, what do we switch? We switch the x and y. Does everybody agree with that? So when I switch the x and y here, I'm going to end up getting x equals 3y minus 12. Well, how would I solve for y here? I would add 12 to the other side, getting me 3y equals x plus 12. And then I would divide by 3, which is what my relation is there. Okay, so in something like that, you have to flip your addition or subtraction first, and then flip your multiplication and division. The two-step ones are a little bit tougher. Okay, and if you do plug 1 in there, that one actually does check out to get all the way back up. So this one is your inverse. A two-step inverse operation is a little bit tougher. All right. Other than that, though, here's your assignment.